Hey class, Mr. Rigger again. Now we're going to be looking at the second page of the 2-2 note sheet. This is the constant multiple rule. I'm going to go ahead and zoom in a little bit so you can see a little bit better. Alright, so now we're looking at the constant multiple rule, which says if you have a constant times a function and you want to take the derivative, that's just the constant times the derivative of that function. You can pull the constant out. So this is really y equals 2 times x cubed, right? Which means y prime is really going to be 2 times the derivative of x cubed. So this is really 2 times, using our power rule, 3x and 3 minus 1 is 2, 6x squared. This is really a 1/4 in front. This is really 1/4 times 1 over x squared, or 1/4 times x to the negative 2. Which means when I do my derivative, I'm going to do 1/4 times negative 2, x to the negative 3, because negative 2 minus 1 is negative 3. Now, 1/4 times negative 2, 2 over 4 is 1/2, so I'm going to get a negative 1/2 x to the negative 3, which I could also write as negative 1 over 2x cubed. This one right here is 2 times square root x. When I take the derivative, I'm going to do 2 times, by the way, 2 times x to the 1/2, right? So 2 times 1/2 x to the negative 1/2. Now, 2 times 1/2 is 1. Positive 1 this time because we had a positive 1/2 to begin with. Here we had a negative number. Times x to the negative 1/2, which is 1 over square root x. That's what my derivative is for C. If I look at D, this is 3/2 times 1 over cube root x, which is 3/2 times x to the negative 1/3. 1/3 because of cube root, negative because it's on the bottom. Now when I do the derivative, dy dx, also y prime, doesn't matter. This is going to be 3/2 times negative 1/3 x to the negative 4/3. If you notice, these are a lot like the problems from the last video. So now I take my 2/3 and my 3/2 and my negative 1/3. I'm going to get negative 1/2 when I multiply those numbers together. X to the negative 4/3, which is going to equal negative 1 over 2 x cube root x, if you remember from the last video. Sum and difference rules. You can add derivatives for each of the functions that you have if you're adding them together. If you're subtracting, you can subtract the derivatives. So the derivative of x cubed is 3x squared. The derivative of 4x is 4, and the derivative of 5 is 0. And now, since there's a minus sign here, I subtract and I add. Of course, plus 0 goes away, and I get 3x squared minus 4. That's how I take the derivative of this. Now, we already took this derivative up above, right here in B. So I know that this f prime of x is going to be negative 1 over 2x cubed. This one here, this 2 root x, I did in C, I get 1 over root x. And since we're adding these two functions together, we add their derivatives. Now, this last one might look a little scary, but not if we take the time to think about what we have here. This is actually negative 1/2 x to the 4th plus 3x cubed minus 2x plus 7 over 16. So this is really just a 1/2 in front. So when I do my derivative, I get negative 1/2 times 4x cubed plus, because I have a plus sign, 3 times 3x squared minus 2. Now, this is really x to the 1, so really 1 x to the 0, which is, all of this is just 1, which is why 2x just becomes 2 when I take the derivative. And then the derivative of 7/16 is 0. So let me clean up. Negative 1/2 times 4 is negative 2. Negative 2x cubed plus 9x squared minus 2 is my derivative. That'll be it for our second video. When we pick up, we'll do sine and cosine rules.